Poor maintenance of your cooling tower can cause up to 70% of a heat transfer loss, making less profitable your industrial process. So today I'm going to show you how to improve your cooling tower's performance. First, I would like to stick up for utilities, because in this young industry where they don't care much about them and they are seen as secondary equipment, where it may be not useful to spare any technology and maintenance, making a tedious equipment operation. So if we put the right technology and maintenance in these utilities, we can control much better the industrial processes. So in cooling towers can bring many type of problems, such as fouling, scaling, and loss of the heat exchange efficiency that will directly affect your production process. So let's start by identifying which are the main contamination sources. First, we have the makeup water. In cooling tower, the water flows in a refrigeration circuit where it could get polluted by different sources. Makeup water that could not have an adequate treatment, supplying poor quality water to your cooling system. The makeup water can come from a poor well, or you have brackish water, or even from a river where the microbiological activity is high. So you will have a lot of organic particles in your system. For example, also in the Middle East, sandstorms are very frequent, so it can increase the suspended solid levels in the refrigeration circuit. Also, the same installation can be a contamination source, as pipe degradation by high and constant chemical usage will release suspended particles to the circuit. So all these particles can eventually decant and affect the water flow and therefore the heating transfer of the cooling system. So what are the types of contamination particles from these different sources? First, we have settleable sludge. Mineral and organic sediments accumulation through the water circuit can decrease the heat exchange performance. For example, a 0.3 millimeter scale on the heat exchange surface will increase by 10% your energy consumption in order to achieve the same cooling efficiency. So you will need to pump more water to maintain the heat transfer coefficient. So you will have heat transfer efficiency problems. You will have a lower flow rate through the heat exchange surfaces. As the flow slows down, it is more likely that particles will decant and settle in the circuit, in pipes, and different surfaces of the system. The faster particles will settle as the flow will slow down. Then you also have scaling. Scales are crystallized depositions that are strongly adhered to the internal surfaces of the system. Once you get a scaling point, this will increase its size exponentially, as other particles are more likely to get stuck on this point, and also increasing the risk of biofouling. So poor water quality will increase the scaling, which will affect the water temperature. So the temperature will be higher. This will concentrate the salts by evaporation, so more blowdown will be needed as the concentration cycles decrease. So you will have more blowdowns, means more makeup water consumption, and also a higher environmental impact. Then you also have corrosion, which can be caused by the presence of dissolved gases present in the makeup water, and also because of the suspended solids. This, of course, will bring higher operational costs, as there will be the corrosion inhibiting chemicals will be less efficient, and you will have also cost in replacement of spare parts and main components. And also you will have, which is probably the worst, is that you have several shutdowns of the cooling tower for this for the maintenance. And finally, probably the worst of all is the biological growth. Biofouling of organic matter on heat transfer surfaces can cause up to 70% of the transfer loss. That is, the transfer loss will mean that you will have a higher energy consumption because you will have to pump more water in order to maintain the same cooling efficiency. Sometimes the environment will also help the biological growth, as the climate conditions will be ideal, and also the lighting conditions. So it will have a strong insulation action for corrosion inhibitors and oxidants. Biocidal or disinfectant to maintain residual dosing, also to avoid Legionella, as Legionella is the most dangerous bacteria for the cooling tower, which can also produce human infections and eventually the shutdown of the factory if the water contains this bacteria.